Now everyone give the heading Transverse Metacenter or simply Metacenter. M suffix T. How we denote? Guys, how we denote transverse metacenter? We denote transverse metacenter by what? M suffix T or simply M, guys. How we denote transverse metacenter? We denote transverse metacenter by what? M suffix, guys. See the word suffix. This T is in suffix. Suffix. What is the meaning of word suffix, guys? Suffix means at the bottom. Rightmost bottom, guys. Rightmost bottom. So here T is in suffix of M. M suffix T. So transverse metacenter, guys. Observe the scenario here. So transverse metacenter we denote by M suffix T or simply M, guys. Now what is meant by transverse metacenter? Transverse metacenter is an imaginary point about which rolling of the ship can be considered at a small angle of hill, guys. What is meant by transverse metacenter? Try to understand the meaning of transverse metacenter. So transverse metacenter. What is transverse metacenter, guys? Transverse metacenter is an imaginary point. What, guys? Transverse metacenter? Transverse metacenter is an imaginary point about which rolling of ship can be considered. About which what, guys? Rolling of the ship can be considered. So what is meant by transverse metacenter? Transverse metacenter is an imaginary point about which rolling of the ship can be considered. So rolling of the ship can be considered for small angle of hill. That is word also important, guys. Considered for which point? For which scenario? For small angle of hill, guys. Try to see the meaning of word. So now what is meant by transverse metacenter? Transverse metacenter is an imaginary point about which rolling of the ship can be considered for a small angle of hill. Now what is meant by rolling? Rolling means what? Just imagine, this is what a transverse view of the vessel, guys. This is what a transverse view. Just imagine that. And rolling means what, guys? What is the meaning of word rolling? Try to see the scenario. About this point, rolling means what? Ship will going to roll like this. So this is meant by rolling. And about this point, ship is going to do what, guys? Ship is going to roll about that point. So that is meant by what? Our metacenter. So that is imaginary point, guys. So now before going further, guys, please everyone write down, give the heading transverse metacenter or metacenter and write down this definition of transverse metacenter, guys. Everyone write down this definition. Now try to see the next point, guys. Everyone. Now I am going to draw the transverse view of the ship. Now for our upcoming discussion, transverse view is our favorite thing because we are dealing with transverse view. So here I am going to draw what? I am going to draw a transverse view of the vessel. Just have a look here, guys, carefully. So this is what our transverse view of the vessel. Now here I am going to show the water line. Here just imagine that this is what our water line, WL. Here I am going to show the center line, guys. Center line of the vessel. Just imagine that this is what our center line. And how to draw the center line, guys, we have studied. Bigger line. How to draw the center line? How to draw the center line? Bigger line, smaller. Bigger, smaller. bigger line, smaller line, bigger line, smaller line, bigger line, smaller line. So in this way we have drawn the what? Center line of the vessel. L, inside that L we will have a what? A C. Now try to see the scenario here, what we have to do and how we are going to approach. So somewhere here, it can be anywhere guys. So for now I am showing M here guys. So this is what our, just imagine that this position is of what? Our M. M means what? Transverse metacenter M, or what we will say? M suffix T. But we generally denote what guys? Generally we denote by M only. But M suffix T also we can denote. Then that is our metacenter. Then here somewhere here we will get a G. G means what? What is the meaning of G guys? Can anyone tell me? G means center of gravity. Then here somewhere here, this is what? This portion guys below the water line. This portion of the ship denote what? Water displays guys. And here somewhere here what we will get? This is what? Our center of buoyancy. And the bottommost point of the ship, what we will say? That bottommost point of the ship is what? Our keel. Now try to see the scenario here guys. A very simple discussion, not that much difficult discussion, nothing much in this discussion guys. Just try to see this, try to see the discussion guys, this one. Now here, position of M with respect to keel. How to get a position of what guys? How to get a position of M with respect to what guys? With respect to keel. That position of M with respect to keel means what guys? Our Km. Position of M with respect to what guys? Position of M with respect to what? With respect to keel. That is meant by our Km. Guys, observe this drawing. Very, very important discussion we are learning. Simple also guys, you may know this discussion. Okay, these are the just basic discussion guys. So here, from here to here, I am going to draw one dotted line guys, so that you will get a more clear understanding. From here also I am going to draw a dotted line. Don't worry, I am going to make them dotted. So this is what what I am doing. This line not from here guys. This line somewhere. One minute. Let me make the drawing proper guys. This line must be from the EM guys. Sorry for blunder from my side. So this line, this dotted line, this dotted horizontal line must be from EM guys. So here this dotted from the keel, another dotted line. So this distance guys, observe what this distance denote? From keel to metacenter guys, vertical distance between keel to metacenter. What we will say? This distance means what? Our, what is the meaning of this distance? We will say this distance as what? Our Km. What we say guys? This distance as our Km. Then this distance guys, the next point that I am going to draw, the distance between keel to B guys. We have seen this meaning of this distance guys. The distance between keel to B. Can you guess guys? The distance between keel to B guys, this distance. So what this distance denote? From here to here, this distance denote guys. Let me make it properly guys. So this distance denote what? Our KB. And then at the end, B to M. What this distance denote guys? B to M. This distance we will say it as a what? BM. So try to understand the meaning of each and every term guys here. So here, so Km will be equal to what guys? KB plus BM. Can we say? Km is equal to what we can say? KB plus BM. So Km will be equal to what? Kb plus Bm, guys. What is meant by Km? Position of M with respect to kill will be what? Kb from here to here, kill to be Kb plus Bm, guys. Try to see the scenario. Very simple discussion, not that much difficult discussion, guys, where we are going to see the meaning of each and term. We have seen what is the meaning of Kb, guys, so I am not going to write down that meaning of Kb once again here. But here Bm means what, guys? What is meant by Bm, guys? Bm means what? Metacentric radius, guys. What is the meaning of Bm, guys? Bm means what? Metacentric radius. Not metacentric height, guys. Bm means metacentric radius. What is the meaning of Bm, guys? Bm means metacentric radius, guys. Try to see the scenario. And this radius must be in what? Meter. And relation for Bm will be what, guys? Relation for Bm. You should know this relation for Bm, guys. Relation for Bm. I center line. I center line divided by volume of water displaced, or I center line. You have to memorize this relation into density divided by what? Delta, guys. Delta means displacement. And here we will get the Bm in what? What will be the unit of Bm? We will get Bm in what? Meter, guys. I will explain what is the meaning of I center line, guys. Don't worry. But before that I will make this relation in the box, guys. I will use red color. And here where? What is the meaning of I center line, guys? I center line means what? I center line means what? Second moment of area. Guys, see the I center line means what? Second moment of area of water plane. Second moment of area of what, guys? Second moment of area of water plane. Second moment of area of water plane about center line, guys. And it must be in what? In m raised to the power 4. It must be in what, guys? In m raised to the power 4. So before going further, what you have to do? What you have to do, guys? Draw this figure, everyone. Draw this figure properly. Write down this discussion. But 1 minute, I am going to add a few more things on this figure, guys. What I am going to do? I am going to add a few more things. We need these things in our upcoming discussion. From the G, I am going to draw another dotted line. From the G, I am going to draw another dotted line. So this one, this dotted. So from here to here, this distance, we will say it as a what, guys? I will use red color pen for this. This distance, we will say it as a what? Gm. Guys, this is very, very important. And then here, this is what our G. And I will extend this horizontal line further. Because we need all this discussion for our upcoming discussion, guys. We need all these points for our upcoming discussion. And distance between G and kill will be what, guys? Distance between G and kill. So this distance, we will say it as what? Can you guess? Not guess, guys. We have studied already. Distance between G and kill. What is the distance between G and kill, guys? That distance, we will say it as a what? Distance between G and kill. We will say it as a what? Kg, guys. We have already studied meaning of kg, guys. What is meant by kg? Vertical distance between kill and G. So before going further, guys, what you have to do? What you have to do, guys? Try to draw this figure. Let me something. Oh, it is too much. So before going further, guys, what you have to do? Draw this drawing properly, guys. Draw this drawing properly. Try to draw the drawing. First of all, try to draw the drawing. Show all the things here carefully. And then write down this discussion about m, guys. Please everyone, complete this discussion from the screen. Please everyone, write down this discussion. Now the next point that we are going to study is what? Metacentric height. Next point that we are going to study is what? Metacentric height, and we denote metacentric height by what? GM. How we denote metacentric height? We denote metacentric height by what? GM. See guys, see, there are two things. One thing is what? BM. Guys, see, one thing is what? BM. This one, distance between B and M, BM. That is metacentric radius. Guys, BM means what? Metacentric radius. And second thing is what, guys? Metacentric height. Metacentric height means what? GM. Distance between G and M. So here metacentric height will be what, guys? Try to see the scenario here. Metacentric height. So metacentric height means what? Distance between G and M. Vertical distance between G and M, that is metacentric height. We have shown already in this drawing. So now here try to see the scenario here. So GM, guys, how we will say GM? Just have a look at this drawing. Just have a look at this drawing. From here to here, guys, distance, see, this is what a GM. From keel to M distance is what? Our KM. Distance between keel to M is what? Our KM. Distance between keel to G, that is what? Our kg. So how we will get a GM, guys? So if you want this distance, guys, GM, if you want this distance GM, how we will get? KM minus what, guys? Kg. Just have a look at this drawing, guys. This drawing is very, very helpful for you. So GM will be equal to what, guys? KM minus what? Kg. And another relation of Km means, what is the relation of Km we have seen, guys? KB. Go through your notes, guys. KB plus BM, and here subtract kg. So in this way we will get the relation of what, guys? GM. And GM stand for what? Metacentric height. What is meant by GM, guys? GM means metacentric height. GM is very, very important term, guys. GM, metacentric height, determines the stability of the ship, guys. GM determines what? Here always remember that higher the value of GM, ship will be more stable. If so always remember one point, just I will not write down in notes because we don't need it that much, but always remember, if value of GM is higher, then ship is what? More stable, guys. If the value of GM is higher, then ship is what? More stable. So try to see the scenario, guys, here. So here GM means what? Metacentric height. Now the next point we are going to see, equilibrium of ship, guys. What is the next point that we are going to see? Equilibrium of ship, guys. So everyone, before going further, guys, 1 minute, before writing equilibrium of ship, just write down this discussion about metacentric height, guys. Everyone write down this discussion about metacentric height. Before that we have written all this discussion. Yes, we have written. So before going further, please everyone write down this discussion of metacentric height. Now we are going to see equilibrium of a ship. First type of equilibrium is what, guys? This discussion needed mechanics also, guys. There is one question. Types of equilibrium in mechanics also. So first type of equilibrium is what? Stable equilibrium. I will explain you what is the meaning of stable equilibrium, guys. In case of stable equilibrium, GM is what, guys? In case of the stable equilibrium, value of GM is what? Positive. That is, and in which case we will have a value of GM positive? When M is above G. When M above the G, guys. M means what? Metacenter. M above the G. In this scenario, this situation, M above the G. So in this case, M above the G. In this case, we will get a value of G, M positive. And in that case, that situation is what? Our stable equilibrium situation. Now what is meant by stable equilibrium? Just imagine that, guys, due to bad weather, there is a water rolling of the ship, and see, suppose ship hit by some particular angle. Ship hit by what, guys? Some particular angle. due to bad weather, guys. Here I am showing a transverse view due to bad weather. So due to bad weather, ship held by some particular angle. But if it is in stable equilibrium, guys, if ship is in stable equilibrium, what will happen, guys? It will automatically come back to its upright position automatically, guys. If ship is in stable equilibrium, it will come back what, guys? If ship is in what? If ship is in what? Stable equilibrium, it comes back automatically to upright position. Okay, so that is meant by stable equilibrium situation. So if GM is positive, that is M above the G, in that case, what will happen, guys? What will happen? Due to bad weather, suppose if ship held by some particular angle, guys, but after sometimes it will come back to its upright position automatically. So this situation of is what, this equilibrium situation is what we will say stable equilibrium situation. So in that, it is happen in which case? When what? GM is what? Positive. Second type of equilibrium situation is what? Unstable equilibrium situation. Unstable equilibrium situation, guys. In that situation, GM will be what? GM is what? Negative, guys. GM is what? Negative. That is M. In that situation, M is what? Below G. M is what? Below G. And what is the meaning of unstable equilibrium? Suppose due to bad weather, what happened, guys? Held gate by ship rolled by some particular angle, guys. Due to bad weather, ship get held by some particular angle. Ship get held by some particular angle, guys. But in this situation, ship will not come back to its upright position. Ship will not come back to its upright position. Instead of that, it will get capsized, guys. What will happen, guys? In that case, in case of unstable equilibrium, ship will get capsized. You got the meaning of here? Here, in stable equilibrium, it will come back to upright position automatically, guys. Upright position. But in this unstable equilibrium, here ship means once ship get held by some particular angle, then it will not come back to its upright position, but instead of what? Ship will get capsized. So that is meant by our unstable equilibrium situation, guys. You got my point? What is meant by unstable equilibrium? So here, so this is what our unstable equilibrium situation, guys. I will keep this transverse view, we need it. And now third type of equilibrium is what, guys? What is the third type of equilibrium? Third type of equilibrium is what? Neutral equilibrium. So third type of, so can you guess what is the value of G is remaining now? We have seen value of GM positive, we have seen value of GM negative, and in third situation, just guess it, guys. Value of GM is what, guys? In this situation, value of GM is what? 0. Here value of GM is what? 0. That is what? When it is 0, guys? Distance between G and M when it is 0. Distance between G and M when it is 0. When they are coincides with each other, guys. When distance between G and M is 0, guys. When they coincide with each other. So that is what, guys? GM is 0 means what? M. Here metacenter coincides with what, guys? Here M coincides with what, guys? Here M coincides with what? G, guys. What we can say, guys? Here M coincide with G, guys. So in this scenario, M coincides with G. So in that case, neutral equilibrium. Now, as per ship, suppose ship get held by some particular angle, guys, due to bad weather. So it will not get capsized, it will not come back to upright position, it will remain in that state permanently, guys. If ship is in neutral equilibrium, in that case, if ship is in neutral equilibrium due to bad weather, suppose ship get held by some particular angle, guys, due to bad weather, ship get held by some particular angle, it will not come back to its upright position, it will not get capsized, but it will remain in that position for forever. So that situation is what? Neutral. Okay, it is not going to capsize, it is not coming back to upright position, that ship will remain in that state forever, guys. So that is meant by our equilibrium of the ship, guys. So got it, equilibrium of the ship, guys. So what you have to do, guys, very simple discussion, not that much difficult discussion. So before going further, 1 minute, let me erase this one, guys, we don't need it. So before going further, guys, everyone write down this discussion about equilibrium of the ship, guys. Please everyone write down this discussion of the equilibrium of the ship.